So now we're going to find the orders. So here we have some example. We're going to find the order of each elements in the group Z3 with the compositions addition. So what is Z3? So Z3 is the collection of a distinct class. So Z3 is a collection of 3 distinct class: 0 var, 1 var, 2 var. So what we're going to do, we're going to find the order of each and every elements of the group Z3. So just let me recall for you what is the order of an elements in a group. So suppose we have a group, so let me recall all that parts. So here we go. So let me recall that if we have a group Z and with the compositions, and if we talk about if we have the identity elements the element of the group G, then if we have an elements A belongs to Z, then the order of A is the least positive integer n. The order of A is the least, so this is the smallest positive integer, least positive integer, this positive integer n, such that, so if we compose A n times, so A to the power n equals to E, which means if I compose the elements A n times, then what we get the identity elements, and this is the least positive integer n for which this thing is whole. So this is for any general group. So also we write in, if we consider the additive group, something like that, if we have a group C with some additions, so see on that group if we have the identity elements, so instead of A to the power n E, we also write n A equal to, we get the identity element E, which means if we add A n times, so this is the least n for which if we add A n times, then we achieve the identity elements. So going to use that over here. So what is the identity elements in this group? So with the compositions addition, so here we have the composition addition. So under this composition, so which is the identity element of the group? So in my last lecture we have talked about that 0 var is the identity element, so we have already done that. So 0 bar is the identity elements of the group, because if I add any element with 0 bar, we get the same element. So here, so let me write that with 0 bar is the identity element, in the group Z3 with addition. So now we're going to find the orders of each and every element. So what is the order of 0 bar? So how many times we have to add 0 bar? So how many times we have to add 0 bar with 0 bar to achieve 0 bar. So that means I am talking about which is the least positive integer n for which n bar, so which means if I add 0 n times, then we get the 0 bar. So it's clear, very clear, we don't have to add many times. If we have 1, n equals to 1, which is the least number 1, for which we get the 0 bar. So order of 0 bar is, so order of 0 bar is 1. So next, how many times, next we're going to find the order of the elements 1 bar. So which means how many time we have to add, n is the least positive integer, so how many the least numbers of times we have to add 1 bar with 1 bar. So if I add 1 bar with 1 bar, we get the value 0 bar. Is this possible to find such an n? So let's check that. If I add 1 bar for 1 bar, so what we get? Just 1 bar, which is clearly not equals to 0 bar. So now if we add 1 bar 2 times, so 2 into 1 bar means 1 bar plus 1 bar. So 1 bar plus 1 bar is 1 plus 1 whole bar, which is 2 bar, and clearly this is not equals to 0 bar. Now what about 3 into 1 bar? So that means we are adding 1 with 1 3 times. So 1 bar plus 1 bar plus 1 bar, this gives basically 1 plus 1 bar plus 1 bar, so 2 bar plus 1 bar, and this gives ultimately 3 bar. So we know that for the group J3, if we add the group J for the J group J3 with these 3 elements, 3 bar is actually 0 bar, because if I divided 3 by 3, then we get the remainder 0. So 3 bar is basically equals to 0 bar. So we get the identity elements. So what is the order of the elements 1 bar? So 3 is the least number of times we have to add 1 bar with 1 bar to get 0 bar. So order of 1, so order of 1 bar is none other than 3. So let's check, so what is the order of 2 bar? So let me erase this part. So what is the order of 2 bar? Which means how many times, so which means how many times, so we have to find the least n, the least times we have to add 2 bar with 2 bar to get 0 bar. So now if I add 1 bar, 1 into 2 bar means we are taking 2 bar at it, just 1 at a time, so we just not adding with anything, so 2 bar is clearly not equals to 0 bar. So 2 into 2 bar, which means we are adding 2 bar 2 times, so we get basically 4 bar, and if I divided 4 by 3, we get the remainder 1, so 4 bar is actually 1 bar. Now if I take 3 times 2 bar, so what we get? 2 bar plus 2 bar plus 2 bar, which is again gives 2 plus 2 plus 2 is 6, which is 6 bar, and 6 bar, if I divided 6 by 3, we get the remainder 0. So 6 bar is actually equals to 0 bar, and we have seen that 3 is the least positive term, least positive integers. So this is the least number of times we have to add 2 bar with 2 bar to get the identity elements. So the order of 2 bar is 3. Okay, I hope you understand that problem. If not, let's see another example. So here we go with another example. So let me erase this first. So if you want to note that parts, just pause the video and take notes on your notebook or anything, so anywhere you can take notes. You can also download the video and check where it is needed, you will use that. So let me erase this part. So what we're going to do, we're going to again find the each order of each elements in the group. So instead of the group Z3 plus, what we're going to take, we're going to take the group Z6. So we are taking a big Z6 plus, so we are going to find the order of each element. So again in this group, so we know that again for this group, if we have as elements, so Z6, first let me write down the Z6. What is Z6 basically? So Z6 is contain the class 0 bar, 1 bar, 2 bar, 3 bar, 4 bar and 5 bar. So they are the all distinct classes. And now what we're going to do, we know that 0 bar is the identity element. So this is the identity element in the group Z6 with additions, not with other operation, with additions. 0 bar is the identity element. So what we're going to do, so how many times we have to add 0 bar with itself to get 0 bar again, and we are finding the least number of times that we have to add 0 bar with 0 bar to get 0 bar. So clearly n equals to 1 over here, because 1 times 0 bar is 0 bar itself. So order of 1 0 bar, so order of 0 bar is clearly 1. So it's very simple. So order of 0 bar is 1. So next we're going to find the order of 1 bar. So how many times we have to add 1 bar with itself to get 0 bar, and we are finding the least number of times we have to add 1 bar with 1 bar to get 0 bar. So now if I add 1 bar at a time, which means just 1 bar, which is clearly not equals to 0 bar. So now 2 into 1 bar means we are adding 1 bar with 1 bar. So that means we get 2 bar. So clearly 2 bar is not equals to 0 bar in this group. Now if I add 1 bar with 3 times, so we get 1 bar plus 1 bar plus 1 bar 3 times. So let me erase this part. So what we get? We get 3 bar. So we know that 3 bar is a distinct elements from distinct elements and with 0 bar. So 3 bar and 0 bar are distinct elements. So 3 bar is unequal to 0 bar. So next, so 4 into 1 bar. So 4 times. So we get 1 bar plus 1 bar plus 1 bar plus 1 bar. So this gives 4 bar, which is again not equals to 0 bar. So similarly 5 bar, 5 times 1 bar is 5 bar, not equals to 0 bar, and 6 times 1 bar is 6 bar. Now if I divide 6 by 6, we get the remainder 0. So 6 bar in the group J6 is equals to 0 bar. So order of 0 bar, order of 1 bar. So order of 1 bar is obviously 6. So next we are going to find the order of the elements 2 bar. So let me erase the whole parts from here. So I hope you are alright with all these things. If you are not, just revise what you have learned till now. So next we are going to find the order of 2 bar. So 1 into 2 bar is clearly 2 bar, which is not equals to 0 bar. So 2 into 2 bar is 2 times 2 bar. So we get 4 bar, which is clearly not equals to 0 bar. So 3 times 2 bar is 2 bar plus 2 bar plus 2 bar. Yeah, we get the 6 bar, which is 0 bar. So order of 2 bar is order of 2 bar in this group. Z6 is 3. So can you find the order of 3 bar? Just pause the video and do by yourself. So let me write, I just left for you to find the order of 3 bar, 4 bar, and I just do the 4 bar. I will again leave the order of the 5 bar. So let me do to find the order of 4 bar. So here this is your task to find the order of the elements 3 bar and 5 bar. So let me find out the order of 4 bar. So how many times basically we have to add 4 bar? So how many times we have to add 4 bar with 4 bar to get the identity element 0 bars? That will be the least number of times will be the order of 4 bar. So now 1 into 4 bar is clearly 4 bar. So we have only 1 4 bar. So clearly that's not equals to 0 bar. So we have 2 into 4 bar means 2 times 4 bar. So 4 bar plus 4 bar is 8 bar. So 8 bar, if I divided 8 by 6, we get the remainder 2. So 8 bar is 2 bar. So in this group 8 bar is equals to 2 bar. So what about 3 into 4 bar? So it gives us 4 bar plus 4 bar plus 4 bar is 12 bar. So yeah, if I divided 12 by 6, because we have the group Z6, we get the value 0 bar. So order of 4 bar, so order of the elements, so order of 4 bar is again 3. So that's the beauty of all that thing. So here we go. So you can see that if we add some positive numbers, basically 4 bunches of positive numbers, so here we can see that we adding the positive numbers, but we are getting some zero values. So that's the beauty of all this thing. So also you can, so there is, I want to just note that all the thing that we can also think the group Z6 or Z3. So ZM, any group like this, as you can think as your watch. So suppose what we do in our daily watch. So if we are doing, so actually our daily watch, which basically work as the group J12 basically. So basically work, not the group, basically is with the set J12 is something like our watch basically. So where we find 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I get something 13, so when get with 13, we say that 13 is basically 1. So we actually 13 is 1. 14 is 2 in our watch after the mid noon. So after the mid afternoon, we say that after the noon we say that the 13 is 1, 14 is 2, 15 is 3. So something like that. Here the basically things. So basically here we go, what we do here, we do the work with the set J12. Similarly, if I think as we have a set Z6, if I think we have a watch, so this is something we imagine that we have a watch with 6, 1, 2, 3, 4, 5, and we have 6. So after we get 7, so here 1, if I 1, 2, 3, 4, 5, 6, if we get 7, so 7 is again 1. If I get 8, this again gives 2. So in this way you can also imagine all the things, all such type of group, all such type of sets as your watch. So that's the beautiful thing. You can think about all the things about congruence class and related groups. So in our next lecture we're going to talk about the subgroups, the concept of subgroups. So now that's all for the today. So thank you for watching.